Threads and processes. Threads are basic means of expressing parallelism in a software program. Threads are part of a process running on exactly one hardware context. Processes are programs running on one or more hardware contexts with a specific mapping between virtual and shared addresses. A process usually has an instruction pointer, some register values, a stack, a reserved memory region active through the life of the process. Let's have an example. In here, I have two cores, core 1 and core 2. Okay. This core 1 or core 2 are an hardware context, or both core 1 and core 2 is a hardware context. In here, I have one process, P1, another process, P2, another process, P3 in here. And P2 is actually using core 1 and core 2 as its hardware context. Inside the processes, I have here 3 threads. Here, 1 thread for P2 running on core 1 and 3 threads running for P2 on core 2. And usually, the application will allocate tasks to be performed on the threads. The threads' basic operations. So you can create them, you can kill them, you can synchronize them. And you have to locate the threads to the cores. So typically you will have a main thread here. The main thread will fork multiple threads. In here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 threads. This thread can synchronize through a barrier, for instance, so they all reach the same program point before continuing their executions. And in the end, the main thread can wait for the threads to join and to complete their execution. And the scheduler is in charge to allocate the thread execution on the cores. The implementation can be at 2 levels. User level threads, in that case the OS don't see them, or the operating system level, and in that case it's managing the thread itself. And in practice, usually you get both implementation mixed. The basic property of a thread. A thread doesn't know what thread created it. All threads in the same process share the same address space. Threads in the same process share instruction, data, file descriptors, signals, and signal handlers. Each thread has a unique thread ID, a set of registers, a stack pointers, stack for local variable, and a return address, a signal mask, priority, and its return value. Thread-safe programming. The issue here is when you have a piece of code that can run on multiple threads, you want it to be thread-safe. That is, if this piece of code is executed by multiple threads, the result must be correct. So every time you have some shared resources, you have to make sure that if multiple threads try to access these resources, everything goes well. Let's take an example with shared variable. So for any shared variable memory location, you want to make sure that there is not 2 writes happening at the same time on this shared variable. Like in here, for instance, you want 1 write at a time. And when you're writing, you don't want to have a read at the same time. So you want to have some mutually execution, you want the thread to be mutually excluded. So usually this is what we call a critical section. And critical section implements mutual exclusion. What kind of overhead do we have with threads? That's the first question. Why using multiple threads when there is only 1 core? What happens when not using thread-safe libraries? Some references: the Multi-Core Programming Practice book, and see you in class.